Now, up till now, we have seen the various operations of the assembler, how assembler will scan your symbolic program and do conversion to the binary representation. All of you clear with this program loops program or any doubt? I'm giving you 2 minutes, just think it properly because this portion is in your mid syllabus. So in the remid, you have to attempt this chapter as well. If is there any doubt, ask me here only. Then only I can start further. All of you start your audio and tell me, is there any doubt with the previous topics in this chapter? Apart from hate also, some other students should inform me, whatever I am asking. Zil, is there any doubt or is it clear? Okay, so now we will start with the next point, that is the programming with the arithmetic and logic operation. Now, whenever we are performing any arithmetic and logic operation, only some of the basic arithmetic operation are available with in the form of instructions. So, the arithmetic instruction we are generally using, that is the addition, subtraction, multiplication, and division. But the basic computer is only providing the addition. So, using the addition operation only, we need to achieve the subtraction, multiplication, and division. Previous example, we have subtracted two numbers. What is the meaning? That we are not having any subtract instruction, but we are having only add instruction. So using the add instruction, we are performing the subtract instruction. Exactly similar way for the logic operation also. Basic computer only provide the three type of machine instruction. First one is the AND operation, another one is the complement, and third one is the clear accumulator. You can consider LDA instruction is also in the form of logic operation because actually it is transferring the logical operand into the accumulator. Now, when we discuss about the instruction in the form of or in the availability in the instruction set of the basic computer, there are two type of instruction. Either the instruction can be the hardware instruction or it may be the software instruction. The meaning of the hardware instruction, that your instruction is already implemented in the form of hardware circuitry devices. So you don't need to think about anything. You are simply using the add instruction, right? But SUB, there is no hardware available with the uh, computer. So we are performing the subtraction in the form of programming language. So software instruction is what? It is implemented by a set of instruction which actually the collection of program only. So what is the advantage or disadvantage? What is the advantage of the hardware instruction? You simply use the instruction as it is, but the main disadvantage of the hardware instruction is the cost. It is more costly, as well as it you need to provide a more additional circuitry to the your basic computer. But in the same way, if I am using the software instruction, my program will become the long and it will take the more execution time. Now this is the example of multiplication program. All of you must be aware with that. Now in the assumption of this program, we are neglecting the sign number, means we are considering only the unsigned number, that is the positive number. If we are doing the multiplication of two 8 cross 8 number, 8 bit cross 8 bit number, your answer must be the 16-bit number in the multiplication. Exactly similar way, if you are performing the multiplication of two 16-bit number, then your result is 32-bit numbers. Now here you can see the simple example. X is holding my multiplicand, Y will be my multiplier, and P will store my partial product. Now actually how it is multiplication is achieved in the form of binary representation. So X and Y. So it will start looking for the Y. Whenever there is a y position value, bit value is 1, your x will be remain as it is, and it will be added with the partial product. Initially partial product value is all set to 0 because we are storing the sum, so it must be initialized to 0. Here you can see the leftmost bit position of y is 1. So that x will be kept as it is, and it will be added with the partial product. So here you can say the now first partial product is same as your x. Again it will check for the position second bit in the y. Again it is 1. But as the multiplication rule, now you have to shift your x by 1 towards the left. So we have shifted the x on towards the left and it is shifted. Now this partial product is added with the shifted value and it will give you the another partial product. Now third bit in the y is 0. As it is a 0, you don't have to do the addition because your production sum will be remain as it is, but the shifting of the x should be done one more time. So in this position you have to shift x, but partial product will be remain as it is. Now when fourth bit position 1 comes in the y, at that time this x is again added with this partial product, and at the same time it will shifted towards the left. So here you can say in the last position. Then this partial product is added with the shifted x and it will give you the final answer. Now how we will do the programming of it? Now we have to shift our bit position both x and y total 8 times. Means our counter is the 8 times. P is in our partial product. So P is initialized to 0. Now E is, what is E? It is our carry. It is an extra bit in the AC in our basic computer, right? So E should be clear to 0 because every time you are taking the value from the Y and you will check whether it is 1 or 0. So that value is shifted into E. Then after we are transferring the content of Y. First we are taking the content of Y into AC. We are shifting the Y into AC. Why? Because we want to check the status of Y. So first it should be loaded into the accumulator. Then after we are performing the circular shift right operation on the AC along with E. So it will check what is the status of this first bit. Now after performing the shifting operation, now you have to keep the content of Y which is rotated into the Y again. After circulation, we are checking the status of E. What is the position of E? If E is 0, then you have to perform some operation. I will come to that point. But if E is equal to 1, what we have seen? If E is equal to 1, then your X must be added with your partial product. That's why it is written here P arrow P plus X. And at the same time, again you have to clear the E. After performing the partial product addition, what you have to do? You have to again take the X and transfer it into AC. Why? Because every time we have to shift X as well towards the left. So now first I am taking X into AC and performing the circular left with AC and E, that is the content of X. And after circulation, again we will copy the content of AC into the X. As all these, whether it means that whether E is equal to 1 or whether E is equal to 0, this rotation or the shifting of the X towards the left should be performed in each step. After shifting, your counter should be incremented by 1. Why counter? Actually, the counter is decremented as our programming logic. But here you know that there is a no increment operation we are using. So we have to initialize the counter to be the -8. That's why we have to increment it and so that it will become -7. If counter is not 0, it again starting with the E is initialized to 0 and same step has to perform. But once counter is reaches to the 0, it has to stop. For the same, here the program is written. Understand the program thoroughly. First, ORG 100. What is the meaning of ORG? That is the origin. The next line after the ORG must be give the address 100. So it is the same as from the flow chart. First we are clearing the E, then loading Y into the AC, then performing the write operation, circular write with the E and AC. Again shifted value is stored into the Y as it is. If that bit, that is a value in the E, is 0 or not. If it is not 0, then it will execute the next statement, that is a branch to the 1. Not 0 means it is 1. So it will execute this. If it is 1, what you have to do? You have to add the value of X in the partial product. So that we have done. Load X into the accumulator, that is in the AC, added with the partial product, and again store the partial product result into the P. Then again we are clearing the E. But if it is a 0 at this position, SZE, E will be 0. In that case, it will skip this particular instruction and it will perform BUN, that is branch unconditionally to the 0. That is over here. Again, if it is 0, then it will simply perform the rotation of the X towards the left. So it will load the X value into the AC, shift left, again shifted value reloaded into the X. Now increment the counter. But if counter is reaches to the 0, here you can see the counter is initialized to -8. X and Y is initialized, partial product is also initialized to 0. Now when the counter reaches to the 0, at that time it will go to the next. If it is not, then it will branch unconditionally to the first line. Is there any doubt in this? All of you clear with the multiplication logic? Unmute or your audio and tell me, is there any doubt with the multiplication program? Should I start with the next program? Okay, I believe that it is clear to you. So now I am starting with the next program. Now the next program, that is about the double precision addition. Now first you need to understand what is the meaning of double precision. So up till now we have considered only 8-bit addition. Partial product we are doing with the 8-bit. But whenever we are performing the multiplication, you know that 8-bit cross 8-bit is your partial product must be of 16-bit number. So two 16-bit number, unsigned numbers, and multiply and result become the 32 bits. Now, when you want, if you want to store the 32-bit number, you require the two memory words. So that two memory words are known as a double precision. So in the exam, suppose they are asking the question that what is a double precision addition? It is nothing but it is the addition of two 16-bit number. Now, addition of two 16-bit number we already perform in the 8085 as well. Suppose here consider that your 16-bit numbers are stored in this way. AH and AL having 16-bit, BH and BL having 16-bit. Your result is in the CH and CL. These are the variable. Actually, these are not registered in the basic computer. They are the memory or they are the symbolic addresses we are using for our program. So what we are doing, first we are loading the value of AL into the AC. It will be added with the BL and store the result into the CL variable. In between, it may possible that your resulted may generated the carry as well. So where is that carry? That is in the AC. That is actually in the E. So before performing the second addition, you have to clear the accumulator. So we have cleared the accumulator and circulate to bring the carry into the 16-bit, that is in the CIL, circular left. After this, so now carry is already generated. So what we are doing? First adding the carry and AH register, and then whatever will be the result of that, that will be again added with BH. So that is your final result, and that is already available in the AC. So I am using STACH, so transferring the content of AC into the CH. So this is all about the double precision addition. Now logical operation. In the logical operation, we have seen only three basic operation is available. First one is the ending, second one is the complement, and third one is the clear the accumulator. Now in this case, if you want to perform the OR operation, so you have to apply the De Morgan's theorem. What is it? X plus y is nothing but x complement, y complement, ended that operation and again complemented. So actually it will give you the OR operation. It is very easy to understand. What is written is whatever is in the operand A, that is the symbolic address, loaded into the accumulator. Then you have to complement the value. Then store or transfer the complemented value into the some another location, that is TMP. Again load the second operand into the AC, again complement it, that is B dash. Now one operand is already in the AC, that is B dash, and another operand is in the temporary, that is A dash. So ending with the temp. So actually I am performing ending of A dash and B dash. And again I will do the complement. So this small logic will apply the OR operations. Now shift operations. Another logical operation is the shift. Only circular shift is provided by the machine instruction in the form of machine instruction with the basic computer. But actually there are two type of shift operation we are using in the programming. One is the logical shift, second one is the arithmetic shift. Logical shift in means 0 must be added to the extreme position. Means if you are performing the shifting towards the right, at that time you are padding zeros on the left hand side. If you are shifting towards the left, in that time you are padding 0 on the right hand side. So this is some simple example is given to you. Logical shift right. What is given is first you have to clear the E. Why we are clearing? Because we want to pad the E, that is the 0 towards the left. So we have loaded the E and then after circular right. So if you are performing the circular right, then that E will be added into the higher bit of the AC. Same way for the logical shift left operation. So shift left, again you are clearing, but now your rotation towards the left side. Arithmetic shift. Now arithmetic shift, the difference is now you have to preserve your sign bit. In sign, where is our sign bit position? That is on the leftmost position. That must be remain unchanged whenever you are performing any arithmetic operations. So first we are clearing the E, then skip if AC is positive or not. It means that if AC is positive, means you have to keep the E as it is. So if it is positive, then it go to the here, that is second instruction, and circulate E and AC will be, because it is a 0 only. But if it is not, then you have to complement the E and then after you have to perform the circulate E and AC. So this is all about the logical operation. Is there any doubt with the logical operation now? So I will start with the next topic. I am giving you 2 minutes. Think and tell me. Again I am saying this portion is in your syllabus of the remit examination. Okay. Now subroutine. I am not going in the detail of the subroutine. All of you must be knowing that why we are using the subroutine. Subroutine, function, methods are the different terminology used for the same concept. When you are having the repetition of the code in your program, what we are doing, we are make it separate that code from our main program and write it in the form of subroutine. So that is the main purpose of the subroutine. Now in the basic computer, how to connect the main program with the subroutine. So you are having the single instruction, that is the BSA, branch and save return address, which will call your subroutine, and at the same time it also store the return address. This terminology you have to remember. The procedure for branching to the subroutine and returning to the main program is referred as a subroutine linkage. So in the Viva, even in the exam, if the question is asked, what is the instruction that can be used for linkaging the between the subroutine, then only one instruction, that is the BSA. Now, this is the subroutine program. Write a subroutine that shifts the content of the accumulator 4 times to the left. Now, this is the subroutine. At the 104 location, you are having the subroutine name SH4, shifting 4 times. Actually, your subroutine will start with the address of 10A. Now, what is the logic actually? This symbolic address SH4 where you have written, that location is actually stored for the return address. Now, how the program will get executed? First is org 100. It means the instruction after the org will be given the address 100. So here you can see that LDAX having the address 100. We are shifting our number. So we are here they perform for the two numbers, and for the two numbers they have performed the rotations. Now loading the value of x, x is initialized in the hex, something like this, and y is initialized is this. So x is loaded into the AC. Whatever is available in the AC, that is, this AC is also in the processor itself. So it can be accessed by any of the program, whether it is a main program or whether it is a subroutine. So actually we are passing the parameter, that is a x, to our subroutine, but using the processor register. So after LTA instruction, I am using the instruction BSA because I want to call the procedure. So BSA HH4. What your assembler will do, it will jump to the SH4 label, means it will look for this. Using SH4, at this particular location, it will store the address 102, that is the return address. After completing this SH4, it has to back to the address 102. So at the SH4, it will store 102. And at the same time, it will store the 10A into the location counter. So after doing this, it will start execution with this. I am performing 4-time left operation. Then after what I am performing, I am shifting the accumulator 4 times left. It means the rightmost bit position should be 0. So that I am achieving with the masking. I perform the masking operation in which previous 3 digits will be ended with F. If it is ended with masking with the 1, it means it will kept as it is. But if it is masked with the 0, then all the bit to be 0. So here it is FFF0 is considered to be the mask bit value. Ended with mask, and after performing that, I am performing branch unconditionally to SH4. Now here you can see the I. What is the meaning of I? That is the indirect. SH4, I am transferring control over here, but actually SH4 is not my the return address, but it is having the address of the return which is at 102. So that's why it is written as a I. It is an indirect. SH4 itself is not return value, but SH4 having some value, that is my return address. That's why it is an indirect. So again, I come back to the 102. Whatever is the shifted value, I am transferring into X. Same way perform with the Y. Y is transferred to the AC. Again call BSSH4. Transfer to the Y and the hold. Now In the previous example, I said that you are passing the parameter, that is passing the value from the main program to the subroutine using the processor register itself. Now there are two ways you can transfer the content, that is your actual parameter, to the subroutine. Either you pass through the register or either you pass from the memory. How to pass through the register, that we have seen in the previous example. Now it may possible your processor having the single register, that is accumulator. So you cannot pass more parameters to the subroutine. So in that case, you are storing your parameters, or you can say you are storing your values or operands in the memory. It may be the memory block or it may be the single data. Now where to put this memory content, that is the most important thing for finding the linkage between the parameter and the actually the subroutine. So data are often placed in the memory location following the call, means after the call you have to put the data. They can also be placed in the block of storage. It means that it is not only one or two value. Suppose you want to store the 100 value, then also it can store. But the first address of the block is placed in the memory location following the call. But if it is a block, you have to put the memory address of that whole block. Now logical OR operation using the subroutine. Now it is same as the previous one, but it is in the form of parameter passing. You are having the x and y two parameters, right? One parameter is in the x, another is y. But we want that x will be passed in the accumulator and this y value, which is actually store my result. But the second parameter is after the call to the subroutine. Here you can see we have written ORG 200. So first instruction having the address 200. Then after I am calling the OR. Or here is my subroutine name. So branch to the subroutine or branch and save return address to the OR. So your control is over here. What it will do at OR, it will store the address of 202. That is the logic, right? It always store 202 in the OR. Then after it we are performing. Now our operand is already in the AC because X is loaded into AC. We are complement the first operand, storing into the temporary register. Now, this is about the first operand. Now, again, we have to take the second operand for the logical OR. So, how it will take? Now, second operand is present in the location 202. Now, where is my 202? It is in the OR symbolic address. So, that's why I am performing LTA OR, but it is a indirect. So it will, after executing this instruction, it will take 3A F6 and store it into the AC. Again it will do the complement ended with the temporary and again perform the whole complement. If it is 0, skip if 0, then to the OR. Where is my OR? Over here. Where is it? It is the return address. But why I am performing this increment and skip? Because actual address in the OR is 202. But after performing the subroutine, I need to start execution with the 203. That's why I am using the instruction ISZ, increment and skip if 0. It is, we are not dealing with the 0 at this point. We are just want to increment the value which is stored at the memory address OR. So it will increment OR to the 203 and then after I am using the branch unconditionally with the OR and the indirect. So now your control is transferred to the 203, that is the STA Y. So now my accumulator result is transferred to the Y. So that's why it is written as a result stored here. So this is all about the logical OR using the subroutine. All of you clear, or is there any doubt with this? All of you present or not? Or you are just logged in and went away? All of you clear with the program? Apart from Danish and hey, some other students also say. Actually, you understand or simply writing yes, yes, yes? Okay. So next program is the block transfer. Now this block transfer program we also done with the 8085. So what here the thing is, or the program statement is, you are having the two memory block. One is at the starting location 100. Second one is the starting location 200, and total 16 numbers you want to transfer. Whatever data is stored at the 100 location, now I want to transfer at the 200. So I am using through the subroutine. So first I am writing BSA-MVE. So I call the subroutine. As soon as BSA instruction will execute, MVE will store the address of the next instruction. That is the address of the 100. This instruction, not 100, but the address of this. Suppose I am written ORG 100, ORG 500 over here. Then 501 is BSA, 502 is at this position. So MVE will store 502. After this, your subroutine will start execution. What we are doing? We are taking the address, that is load the MVE. MVE is not the address. MVE is also having address, and from that address we are taking the again one more pointer. So that's why it is an indirect. Store that value as a form of pointer. That is my pointer value is now 100. Again I increment MVE. Again the same concept. Where is my second address? At the next location. So I have to increment MVE. So again I will perform ISZ increment and load that value again into the AC indirectly. Again store it into the pointer 2. Means pointer 1 is pointing to 100. Pointer 2 is pointing to the 200. Then 16 minus 16 also I have to load into the counter. So that's why here the three symbolic address at the last, PT1, PT2 and CTR. So again I am increment ISZ MVE, load MVE value indirectly into the AC, transfer AC to the counter and increment ISZ MVE, because after finishing the subroutine I have to jump to the halt. What you understand by this? How many parameters we are passing? In this program, we are passing three parameters, 100, 200 and minus 16. So it is actually the block. So whenever you are passing the block of the memory, at that time, your data must be after the calling of the subroutine. After this, it is very easy to understand. Now, after this, I will perform load PTR indirectly into the AC, transfer AC to the PTR2. Increment both the pointer, even the counter. If it is not 0, continue with the same. If it is 0, again I have to branch unconditionally to the MV, that is the halt, that is a halt address of the HLT. Now, input output programming. Clear all of you with the block transfer? All of you clear with the block transfer? Okay. Now the input output programming. Input output means up till now we are assuming that our data is stored in the memory. But suppose we are taking the input from the keyboard and we are displaying the output on the console. In that case, we have to use the INP and the out instructions. So whenever we are writing any program, so what is program? Program is nothing but it is a collection of symbols which will form some type of programming language. And what is that symbol? Symbol is nothing but the string of characters. So each character requires the total 8-bit code. So for input, we are using the INP instruction. So a binary coded character will be entered and it will be entered through the INP instruction. Exactly similar way, now user had entered, but how user will get confirmed whether the instruction is or the value is entered properly or not. So we are displaying onto the console as well, same time. So in that case, we are using the out instruction. Now input and output one character. So this is the routine for the input a character and this is the routine for output one character. Now see, what I said, suppose I will enter A from the keyboard. At the same time, A is stored inside the computer and it will also display to the user. Then and then only user can confirm that I entered the proper character. So in that case, you have to use this particular logic. What is it? First, it will check SKI, that is the input flag. Skip if input flag is 1. If it is 0, then branch unconditionally to this label. Means it will continuously checking whether any input is available or not. As soon as your flag becomes 1, it will skip this instruction and jump to the INP. So it will take the input. Now whatever input we are taking, that also store to the or print on the output, that is on the screen. So we are using the out. And at the same time, we are storing the value in the AC. When you use the INP instruction, the input value is going to come into the AC. So transfer the AC to the one of the location, or you can say buffer, that is the CHR. And this is the simple store or input a character from the keyboard. Exactly similar way, suppose I want to display onto the output. Now, what happened in the output? Whenever I am using the output, suppose CHR only is used. First, I have to take into the AC. Then I need to check whether my output device is ready or not. So I will check the output flag. If output flag is 0, it means there is no character available in the AC. If it is 1, it means I have to display the output and the halt. And then after, you can see what is the value of CHR, that is the hex value of 0057. Now subroutine to input and pack two characters. So this is the IN2, it is one subroutine. It is not given anything. Then after we are performing SKI, means it is the combination of two inputs and we have tagged that two input at the one location. What we are doing, we are checking the input flag. If it is not, we are in the loop. As soon as we will get, we are input first character, display it, and we are calling the BSA, that is branch and store return address, into SH4. Now what we have seen in the SH4, that is shift left 4 times. This routine we have already seen in the previous slides. Right? Now why we need to shift? Now, whenever we enter the data is on the leftmost position. We want to pack two character in the one memory location. So, whatever character is entered first, that must be shifted left. And then after second character is input and put it into the proper position. That's why it is shifted the value 4 times. And 4 more times means because we have to shift 8 bit, total 8 bit number. Your one memory word is of 16 bit, right? So actual shifting is of 8 bit. So that's why we are calling SHA4 4 times. Then after again we are performing the same. We are again checking the input, taking another input and again complete the output and transfer unconditionally to the same routine. So at one memory location, we will get the packed two characters. To store another next program is to store input character in buffer. It is very similar to the previous one. Here you are having the buffer ADS. Buffer starting address is given as a 500. So we are transferring ADS to the AC and that is actually the pointer. So that is a buffer pointer. We are taking the BS IN2. IN2 is this routine. So we are taking the input packed two characters. Then whatever value we are storing in the AC that we are transferring to the PTR, but indirectly. Then increment the pointer by 1. If it is not 0, continue with the input. If it is 0, then you have to add. This is the to store the input character in buffer. Comparison of two words. Now we want to check whether two enter words or two words are same or not. So we are loading the word 1 into the AC. Now comparison, there is no compare instruction available in the basic computer. How can you do the comparison? So actually if you subtract two values, then after if your result is 0, it means that two values are same. The same logic we are applying over here. Loading one word into the AC, complement it, increment. This is the logic of the subtraction. Add with the second word. So we will get SZA. Means whether that flag Z is 0 or not. Whether your AC is 0 or not. So if AC is 0, it means keep and 0. So this statement is keep and it will execute unconditionally, that is equal, that is branch to equal routine. If it is not, branch to unequal routine. And last topic, that is the program interrupts. Before starting, all of you clear with it? Is there any doubt in the previous input output operations? Should I continue with the next last topic? Okay. Now program interrupts. Program interrupts, what is the interrupts? What is the purpose of the interrupt? That also we will discuss in the previous chapter. That is whenever we want to interrupt or we want to do the some other task from the processor and we have to halt the processor, we have to interrupt the processor. What is the general meaning of the interruption? That is a disturbance. You want to disturb the processor and you are informing the processor that now perform my task and stop your work. It may be possible that your processor will stop its own work and give the priority to your work. It may be possible that processor first finish its own work and after some time it will perform your works. So that is all about the priority of the work already decided by the processor inside. So this is all about the processor. Now, these are the steps that must be taken when your control is transferred from its current execution to the interrupt routine. What it has to do? It has to save the content of the registers, current registers, that is the processor registers. Check which flag is set. Means it has to check whether the input is wants to interrupt me or whether output wants to interrupt me. So it is a checking of the flag, input and output. Whatever is flag is set, service that device whose flag is set. After servicing the devices, it will restore the content of the processor register and at the same time it has to turn on the interrupt facility again and return back to the running program. These six steps we will write in the program form. This is the last slide for the today's lecture sessions. Here you can see now line number 0 and 1 that you don't have to include in the program. At the 200 location SRV, I am having this service routine. Then after at the 100 location, I am the instruction CLA. This is my program. 100, 101, 2, 3 and 4. This is my program statements. How interrupt is actually work. Now 0 and 1 are the addresses which are only used for the interrupt routines. It is not accessible to the user. What happens? Suppose I am at the line number 103. I am executing the add Y instruction. At the same time interrupt occurred. What happened? As soon as the interrupt occurred, your program is transferred, your location counter is loaded with 0, zeroth location. At the 0, it will store the return address. What is the return address? That is the 104. So at the 0th location, it will store 104. And as soon as this will be executed, again LC will be loaded with the address 1. And at the first location, it is having the branch transfer to the service routine. So branch unconditionally to the SRV. It jumped to the SRV. Now these are the steps which are mentioned previously. What are the steps? That clear the accumulator, store the accumulator, right? So store accumulator to the temporary register, because we have to store the processor registers. Which are the processor register? AC and E, that is generally used in the programming. So we will store AC into some location SAC, then we will move, that is the rotation circular right, and we transfer E to the AC. Again transfer the AC content into the location SE, name is given. So actually SE location will contain the E, SAC will contain the AC. Then we will check which flag is set, whether input or output. If input flag is set or not, if it is not, then go with the next, and next will be output flag. If it is set, then take the input and display and store the value at the PT1 indirectly, and skip if 0 to the pointer. Next, if input flag is not set, then it will check for the output flag and branch unconditionally to the exit if it is also not set. And after the exit, it will again load the value of E to the AC and rotate left. So now original E value is shifted into E. Again SAC is transferred to AC. Turn interrupt on using the ION instruction. And lastly, it will perform the branch unconditionally to the ZRO, that is zeroth location, indirectly. Why? Because actually zeroth location having the address 104, and your computer or your processor has to start execution with the 104. So this is the all about the interrupt service routine. So this is all about the third chapter. Is there any doubt with this?